Good day, educators! Welcome to BSED Math Easy for Logic and Set Theory. I am Sridin. Here are our learning targets today based on teaching mathematics the easy way. First, define successor sets, inductive sets, and induction principle. Next, discuss the axiom of infinity and successor sets. Next, discuss Piano's axiom and recursion theorem. And then, define and give examples of transitive sets. And lastly, discuss the arithmetic and ordering of natural numbers. As per your learning task for this week, you will define and discuss natural numbers. Work on learning task 1, 2, and 3. Do assessment exercises and answer reflection tasks. Back in the previous module, we learned the axioms of Zermelo and Vrenkel, the most prominent system of axioms for mathematics, abbreviated by ZFC, where the letter C stands for the axiom of Joyce. Today, let's explore more about natural numbers. Let's take a look at the learner's task. Here's an output of a pre-service teacher whose answer asked about natural numbers.
Good morning, everyone. My name is Ella Sorbas, a pre-service teacher. Today, I will be showing you guys my performance test about natural numbers.
Hi guys, welcome back. This is still Ella Sorbas, your pre-service teacher for today. Now, let's talk about transitivity. We have learned that being a member of a set does not necessarily make you a subset of that set. And sometimes, the members of a set are all subsets of that set. And when that happens, we call that set or class transitive. I hope I'm making sense. Now, let's have a little game. It's gonna be very simple. Let's call it transitive or not transitive. So this is what will happen. I will be flashing sets or classes, and you're gonna determine, or we're gonna determine one by one if these class or sets are transitive or not. Are you ready, guys? Okay, let's start.
Game! Let's start! Here are the sample sets that we will determine if these are transitive or not. We have set A that has B, C, and D as a member. Set B, which has C and D as an element. Set C, which has B and D as an element. D has an element of B and C. And another set is E, which has F, G, H, and I. Set F has F and G. Set G has only F as a member. Set H has F, G, and H. And set I has B, C, D, G, and F as a member. Remember, transitive is a set such that all the elements of the set are also subsets of the set. We're going to say that set A is transitive such that element B, C, and D are all have to be subset of A. What about the set of B? B has an elements C and D, where C is not a subset of B because B doesn't have itself as a member. Thus, set B is not a transitive. Let's move on to set C, where B and D stands as a member or elements of C. Set C is also not a transitive because set C doesn't have itself as a member. Are you following? Moving forward to set D, where B and C act as its elements. And for the same reason, set D is also not a transitive because it doesn't belong itself as a member or a subset of itself. At this juncture, I leave you the rest as our activity. Good luck! Happy answering!
Thank you for connecting with us at BSED Math TV, your quick guide to teaching mathematics. See you next time. Happy teaching!